Okay, then I might take it away. So my first question would be, what is the most impressive achievement of a particular machine learning technique that you have observed? So we have heard about transfer learning. We have learned about data augmentation. We have learned about multitask learning. Did any one of these individual techniques really make a difference? Maybe let's start with Lingli.
Yeah, thanks. Thanks for the question, and also I want to thank you this job forum for the this opportunity to have me be here. So it's very nice to be here. So for the achievement, I may say during this our autumn project, we have achieved quite a good result from like first of all we explored the different type of the method in deep learning, and we started from the zero, and now we are uh, dive in this deep learning in this AI development. So we know more during our project, and also about may say the achievement so far. I think the best thing is we got very good result for building detection, and also we have had this evaluation from our expert. I think this is a very big result. I mean, not only for like a research point of view, like for publication or write papers, but we put those method. It's ready to be used in practice because we result has been evaluated by our experts. So it's a big step forward, I may say. When I had some conference or workshop with the other countries, and they admired about what we have achieved. So I'm appreciate about this the people work in this project, and also I'm proud of the achievement what we have so far.
Thanks a lot, Lingli. So maybe Christian, as you also engaged in this ATMU project, I remember hearing about data augmentation you have used.
Yeah, actually, that's one thing that really did improve. Also, the fact that we used the whole data set and then we take from a random location the tiles that helps fight the overfitting problem. Because we have quite a small amount of data, you could say.
Yeah.
Because it's so laborious to digitize, and we don't have the possibilities in this project to really do huge areas.
Yeah.
So those did really improve the results quite a bit. Yeah.
There, I was wondering, did you also take into account some physical knowledge for data augmentation? Like I have seen you have used random rotations of tiles, but for example, that what I had in mind, but which might be difficult to implement, like knowledge that a water typically doesn't flow in closed cycles. So water runs from higher place to lower places.
I think that's the case for natural streams, yes.
Yes.
But then you have beaches, and
Yes.
actually you might have like a ditch somewhere in the middle.
Yeah.
Nothing where.
Because one very useful property of data augmentation techniques, as I see it, it's very convenient to bring in domain knowledge, like experts. So because how would you bring in like a hydrographic model or fluid dynamics? And one way to bring it in is to use this physical theories or physical knowledge to simulate data. So that's why I was thinking of bringing in this background knowledge or domain knowledge using this data augmentation.
Yeah, that's an interesting idea, and we have actually started to talk a little bit more with people with domain expertise, and sort of the point of the first iteration here has been only to see, well, what can you get with this kind of simple solution.
Yeah. So you have some pretty good ideas how to go further.
We have some ideas how to go further, and we'll see where we get.
Very good, very good. Okay, then Niko. So what particular technique, machine learning off-the-shelf technique, did you find impressive, or where you could see a clear benefit?
We were mostly focused on UNet, and we've been really impressed with that. We've kind of been looking for other options as well to like compare and see if we might benefit from like implementing some other models. But so far, actually, the results from UNet have been so impressive in their own right that we haven't really like put much effort in changing our methods. Of course, one of the things in our project is that we've been trying to keep everything as simple and streamlined as possible, as we are kind of doing this with relatively limited resources, and that's been really useful for that kind of scenario.
Yeah, may I ask, did you have in your team some data scientists by training, like some people who studied machine learning at university level?
Kind of no. That kind of expertise was brought by a private company to
Okay.
our project. So our model was to buy the kind of method development from outside, and then we had one archaeologist with some kind of coding experience. That was me. So my challenge was to kind of jump into a moving train and just.
Yeah, as I see, one of the big drivers for the success and the hype of deep learning or machine learning in AI is this increased usability or ease of use of technique. Because you don't need to study applied statistics for 5 years at the university anymore. You can buy it as a product. So you can buy as a product image segmentation using UNets.
Yeah, absolutely. And if you kind of know what you want to have, you can kind of buy like a product that's tailored to your needs pretty much.
Yes.
It isn't necessarily even terribly expensive, so it's quite easily available to pretty much everyone.
Yes, yes. Thanks a lot. So I see we have a question for Niko. So the question is about other heritage agencies. Do you have collaborations with agencies in Sweden or Norway, or do you know to what extent they use AI and LiDAR?
Yes, there are quite a few other agencies doing something similar. So, for example, in Norway and Sweden, they are doing something similar. In Norway, they have been doing this for a couple of years now, and I think they're pretty advanced at the moment. They use slightly different methods, so they're really interesting point of comparison to ourselves. The Swedes have just begun. They have, I think, at least 3 different projects that they are trying to combine later. And also in continental Europe, for example, in the Netherlands, they have really advanced project. They are using like multi-class detection models and so on. Yeah, there are plenty of similar projects and things going on around the world at the moment.
Yeah, and this example also shows that one of the key benefits or abilities of machine learning, this transferring of knowledge or transfer learning. So if you're able to detect this, as I understood, kiln sites, charcoal, kilns, if I remember correctly, this seems to have been very important for people earlier for a good reason. So if you know how to do it in Finland, you might be able to use that knowledge to do it also in Sweden or Norway, and maybe use, that's what I also would like to add the question, do you take into account also, as in the other applications, domain expertise, like people or scientists who study the behavior of people, like anthropologists? So they could tell you if there is this kind of site, like a kiln, then there should be within 100 meters, there should be dwellings.
Let's say, yeah, to answer the first part, some of the training data is usable pretty much over the world. For example, the tar kilns and charcoal kilns are pretty standard features that are built using the same manual books, really. So they are the same, and we can share that kind of data with pretty much everyone, and it's usable as it is. And the second part, we are that kind of experts ourselves, so that's kind of our point of departure. So we have that kind of archaeological knowledge what should be nearby. So yeah.
And just to go a bit more technical, how do you bring this in? For example, I mentioned before, data augmentation would be one such opportunity. So if you have an image where you know there's a certain dwelling, then you could create a synthetic new image that you would hypothesize another dwelling that could look similar, but maybe a bit rotated, slightly different.
Yeah, we've been doing data augmentation.
Yeah.
That's, of course, we are working with pretty limited data sets, especially with like the dwelling depressions. So we're doing the same rotate, mirror, like flip axis kind of things. Also, we usually take like 2 random snapshots of each like object in our training data set to like create randomly centered versions of the same images.
And do you use, but for this, this seems to be very, so we have an echo here, sorry for the irritation. This seems to be a standard or rather agnostic ways to augment data. So like this, one of the cat images. So a rotated cat image is still a cat image, but when you talk about dwellings or archaeological sites, you might have additional knowledge, like you need to have a certain configuration of buildings in a house. So you could generate new images by using a different variation of a typical old Finnish village, so to say.
Yeah, that's an interesting proposition. We haven't really thought that. We've mostly considered using that kind of information for filtering the data that's produced. So that if we kind of know that, for example, Stone Age sites are in a given area, they must be at least 20 meters above the sea level and not much higher than some certain height. So that helps in like limiting the amount of data we have to go through and verify.
Yes. Yeah. As I mentioned, I think this could be a convenient way to bring in domain knowledge, like from anthropologists in the data augmentation, because this just means you have to enrich your data set by new synthetic data points, whereas other ways to bring in domain knowledge could be to think about specifying a new model architecture, like changing the unit, which might be considerably more difficult. For such an approach, you might need to have a university degree in machine learning, maybe. But in this data augmentation, I think this is really one of the most convenient way to bring in this domain knowledge. Okay, yeah, that was a great first round. So I would like then to kick off the second round of questions, which is, of course, after the praising of machine learning, what was a main challenge in your specific field where maybe the promise that you expected or that you heard about machine learning didn't really materialize yet? So what is a main challenge? Maybe again with Lingli.
Thanks for the question. I think at the moment the most challenge is about because for the traditional neural network we only input data like the certain, for example, images, and but in our geospatial field we have the LiDAR data, point cloud, which is the 3D, and the images usually it's 2D, and how to like combine those data set and to use at the same time to be beneficial for the final detection. So that's kind of a challenge, because at the moment for the LiDAR data we have the X, Y, Z and also intensity value. So when you nowadays when people how do they use together with images, they use like X, Y and Z, or X, Y and intensity value. So that means something missing from the LiDAR data when you are using together with images, because you transfer the LiDAR data 3D data set to the 2D, something might missing. So and another thing is like somebody to individually only use the LiDAR data for the classification, or only use the image for classification. But our challenge, I think, in the future might be like how to use them together in the neural network. So that will.
I hear that data is a main challenge, and I remember also from your slides where you showed the time allocation. So most of the time goes into gathering training data.
Yeah. I think because actually in National Land Survey we have a lot of countrywide open data set, like a topographic database, which has a lot of building vectors and the roads and such. But why cannot we use those? Because the building vectors from National Land Survey topographic database was from the footprint, the bottom of the buildings. But from images, when we use the machine to detect, so it's from top of the buildings. So there are some kind of different, like when we teach the machine how to detect the features from images, we have to have kind of like an outline you fit for the images. So we cannot use the original kind of building vectors from the open data source. So this is a very challenge, but luckily we had some trainees and we had several people like helping, especially for this manually, like for high quality training data collection.
Yeah.
So it helped a lot, and finally we got the result. It's, I think, beneficial from the high quality training data.
Yes. Yes.
Yeah.
And there was a reason why I mentioned that data is the main component in the beginning of the event,
Yeah.
because I see also this as the most challenging part. And maybe Christian, also you can confirm that the most work goes into data.
Yes, that's the by far the most difficult part. Like especially for us, where you have ditches and streams, and they can be quite different from each other, and they're not that clear even in the terrain. If you go there and look at them, you're not always sure, is this a ditch, is this a stream?
Yeah. Okay, so you also confirm, and I guess also you, Niko, the most challenging part is the data part for machine learning and AI.
Yeah, there are like two challenging parts. One is of course the data. We have exactly the same problems that like gathering the training data is not that simple, as like the objects you are trying to collect are not always that similar and might be really difficult to like detect or like to conclude that, okay, is this something I want to have in my training data or not? And the other challenge is something that comes after the machine learning phase, is actually making use of the huge amounts of data it produces. That's actually one of the main challenges for us, as we're trying to like bring unprecedented amount of data to an already existing process, and it's proving quite challenging in many ways. So.
Yeah, that's actually a good point. I was thinking of, I heard a long time ago when I started project management during my studies, we heard that there's this new paradigm. When you plan to build something like a train, you make a full life cycle. So you not only plan how to build the train, but also you will recycle it afterwards. And I was wondering, do you have already such initiatives regarding the data usage? So at some point you cannot store the data anymore, because I guess the memory your institute has available is also finite, the storage capacity. So do you have already a plan when and which data to erase?
Kind of we do, and well, we've been like starting from the other end, which parts of the data we want to actually keep and for what kind of uses. So we've kind of made a plan of which kinds of data we can publish, and maybe have it in some kind of place that kind of keeps it long term and like available to everyone. And then of course part of the data must be like added to our like registers and databases that we use daily, and that's kind of the other part. And then all the rest we are kind of prepared to like ditch. It's like we're built our system so that all the rest is kind of replaceable quite easily. So we are kind of concentrating on the most valuable parts.
Yeah, and I guess it's quite challenging to find out the most valuable parts. And also, it might be not a 0-1 decision, so either delete or keep it, but you might only keep a more coarse version of data, like data aging techniques. Yeah, and I was wondering, is it the National Land Survey? Do you have these long-term plans for how long to keep data, when to erase data, or which parts of data to keep? If I might ask Lingli again.
Yeah, in National Land Survey, we have this topographic database which is open to the society, so
Yeah.
everybody. And annually, we had this updating, data updating, like map updating. So we keep up the latest version of the objects and the changes, and we manage it like that.
Mhm.
So it's a stay there. I mean, all the time.
Yeah.
You can download when you need, and so there's no kind of time limitation when it will be there, but it will always be there.
Okay.
So you can use like any time when you need. You just download from the website. So
Mhm.
just search open data from National Land Survey of Finland, so you will find the link, and very handy.
Yes. Okay. Then, yeah, maybe the last round of question. I would be interested in maybe one of the most difficult aspects of using machine learning, to know when to stop. So when you know you cannot go any better. So this UNet architecture with this number of layers is optimal, or there might be still some benefit to reap. So do you have such ultimate gold standards for accuracy in detecting buildings? Or is this, and in many cases, you don't have such a benchmark. You don't know, principle, if you can do better or no. You can only find out if you try out a new method.
Yeah, I think in our case we tested like with the different kind of, not only UNet but with the others.
Yeah.
But then we compare what's the performance from the different your network.
Mhm.
And also with the UNet we had quite the deep kind of experiments. For example, first of all, we only use the images in the
Mhm.
UNet, and then we noticed we can use the different, for example, color spaces. That's the one thing. We can add one more channel in the input data. And also later on we also put the DEM and the DSM in like more channel in the input data, so
Yeah.
to improve the result.
Yeah.
So we go in that way, like in wide way. We tested it with a different type of the neural network. We also go the deeper way, like with the UNet, and to get improve the result with the one certain of the network.
Thanks a lot. Christian, do you have a gold standard for detecting ditches and streams?
Not in terms of like a threshold value we would like to get to, but mainly I think if we look at the errors that makes
Mhm.
the network makes, then if we can explain those, and we know that we can't improve that with another model. Like if the problem is in the input data or in the training data itself, then that's fine. But we still have maybe a few areas where we could improve with trying out different models, and then it's just how much time do we have in this project, and resources, where the time sort of stops that okay. So there's two possibilities.
Yeah.
We don't have enough time,
Yeah.
or then we can explain all the issues
Yeah.
that it finds, and then it's fine.
And would you say that the deep learning methods that you're using, they're already outperforming gurus that look at an aerial photo and see there's ditch, the stream here and there? Is it already on par, at least, with humans?
I would say it's sort of similar. Well, I would say people still outperform the machine learning because especially when you have some kind of issues in the point cloud or these issues that we have, streams, especially natural streams, we can see quite well where it actually goes, but the machine learning algorithm doesn't really still find those.
Yeah.
So at the moment, I would say still the human outperforms the machine, but
Yeah.
but it's actually, we are quite impressed with how well the UNet also performs.
Thanks. Then Niko, what is the benchmark in your case? I mean, it might be hard to be sure. People now find all cultural heritage sites because humans might have been in every square meter around Finland at some point of time.
Yeah, it kind of depends on the application currently at hand. So we have like different requirements for like detecting really numerous sites like Tarkins. Then we would like to have as little false positives and that kind of problems as possible. But if we're trying to find something else, like the dwelling depressions I've been talking a lot, then we might be prepared to accept much like limited performance as long as it finds something that's potentially an archaeological site, and spend much more time in actually looking at the results. And it would be a huge thing to find even like a dozen new sites in that kind of scenario. So it really depends on the case,
Yeah.
what we are like prepared to accept.
By the way, is there a legal ground or framework who defines what cultural heritage site? Yeah, I guess it's by definition this cultural heritage site, like the UNESCO on a
No, there is a Finnish law on archaeological cultural heritage.
Mhm.
Kind of defines what's protected by that law.
Mm.
Of course, it doesn't cover all kinds of cultural heritage objects. So then there's a huge amount of stuff that isn't covered by the law, but we kind of would like to protect and use. There are different instruments for defining those. It gets a bit
Yeah.
messy.
And is this law, just to give an idea, is this like if at this site there have been baked tiles and there have been baked bread, then this is a cultural heritage site?
Well, it could be.
Yeah.
There is kind of a time limit for like defining what's like covered by the
Yeah.
law on archaeological cultural heritage, and then all the other cases are like case by case decisions, basically.
Interesting. Okay, thanks a lot. I guess we are out of time. It was a great event. I really enjoyed also the panel discussion, and I look forward to some follow-up events. Thank you.